Next up in 3.2 day 1 is doubling and half-life. So this is going to use this is going to be the first of two examples. This one is going to use the same population model that we had before, but just thinking about what happens when we double something, what happens when we cut something in half. So doubling means that we have a 100% increase. So if the rate is 100%, that converts to a decimal number of just 1. And so we would see 1 plus 1 in there. So whenever we're doubling, we just put a 2 on the inside as the growth factor because that's really what it is. When we're halving by 50%, it's a 50% decrease. That means that we're doing 1 minus 0.5. So that's why you'll see the 0.5 in here. These two just basically take into account the original function as you see there. So for this first example, we are going to talk about if a population of bacteria has an initial population of 250 and doubles every 7.5 hours, what is the population after 20 hours? So in this case, as I mentioned, the variable t can be hours, weeks, days, whatever you want it to be. And in this case, they're saying hours. So we start with the fact that this is doubling. And so we're going to use this formula up here. And so P of t, t being the number of hours, we're going to start with 250, and we're going to double every 7.5 hours. Now this is where it gets a little bit tricky. This is where you'll want to pay attention if you're doing homework problems, is that we double every 7.5 hours, but how does the 7.5 come in with t? Well, think about it. If we doubled every hour, then we would just use t because that's just very simple ratio to work with. But if it's 7.5 hours, we're going to think about a full doubling period would be 7.5 hours. So what we're going to do is this. We're going to do t divided by 7.5 because that means if we don't quite get to the full 7.5 hours, we at least have something to represent it, and that fraction exponent will help us to get the value that we're looking for. Now, once we have this function taken care of, it wants to know what is the population after 20 hours. So the only thing we really need to do there is just plug in 20. So 20 hours, 250 times 2 to the 20 over 7.5. And if you punch that into your calculator, then just let the calculator do the work in this case, you're going to get about 1,587.4 bacteria in this population. So that's the first example for doubling and half-life.